Welcome to Esther Equation Corner. So today we have this triangle to resolve. We have that the opposite side of the triangle is m, the adjacent is m squared, and the hypotenuse is m to the power of 3. So for us to resolve this, we need to recall the Pythagoras theorem. Pythagoras theorem, where we have that AC to the power of 2, which is a hypotenuse, equals AB all squared plus BC all squared. So when we impute these values, our AC is m to the power of 3 all squared equals our AB is m all squared plus m squared all squared. So from here we have 3 times 2, we have m to the power of 6 equals m squared plus m to the power of 4. So when we move these variables to the left hand side, we have m to the power of 6 minus m to the power of 4 minus m squared all equal to 0. So from here we can factor out m squared to have m squared, brackets open, we have m to the power of 4 minus m squared minus 1 all equal to 0. It simply means that m squared is equal to 0 and m to the power of 4 minus m squared minus 1 is also equal to 0. So from here we have m to be equal to 0. So resolving this, let m squared be equal to x, so that we'll have, so this can be written as m to the power of 2 further raised to the power of 2 minus m squared minus 1 all equal to 0. So if m squared is equal to x, we have that x all squared minus x minus 1 all equal to 0. So this is a quadratic equation, and for us to resolve it, we have the quadratic formula as x equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Our a is equal to 1, our b is equal to minus 1, and our c is equal to minus 1. So when we impute these values, we have x to be equal to minus 1 plus or minus, our b is minus 1 all squared minus 4 times 1 times minus 1 all over 2 times 1. We have x to be equal to 1 plus or minus, we have 1 plus 4 all over 2. So our x is equal to 1 plus or minus root 5 over 2. So it simply means that x is equal to 1 minus root 5 over 2 and 1 plus root 5 over 2. So this is case 1 and this is case 2. Our case 1, we have that x is equal to 1 minus root 5 over 2. So this is less than 0, but since we are looking for distance, and distance cannot be less than 0, so case 1 is rejected. So we'll consider case 2, where we have x to be equal to 1 plus root 5 over 2. But let's recall that our x is equal to m squared. It simply means that m squared is equal to 1 plus root 5 over 2. So this is our adjacent. So from here, m is equal to the square root of 1 plus root 5 over 2. which is our opposite, and m cube will be equal to 1 plus root 5 over 2 times the square root of 1 plus root 5 over 2. So we have the third side of the triangle. Thank you for watching Esther Equation Corner. Subscribe and hit the notification bell so you don't miss out on any of our solutions.